Welcome back, guys. Now in our previous video we were talking about empirical formula. Now on the board I want to talk about molecular formula. Before I go straight to this question, I have to give a brief explanation under the relation between empirical formula and molecular formula. All right, so there are some questions under molecular formula that they give you the parameters, they give you what you want, and then they'll give you the weight of the compound directly, or they'll give you the vapor density, then you have to find the weight of the compound, which is the mass of the compound should be approximately 2 times the vapor density. So it is an approximate value 2 times vapor density, but for now they don't actually give us vapor density. They give us some parameters for us to know that this is what we have to do. All right, now we'll talk about the relationship between empirical formula and molecular formula. Now let's say we have a compound CXHY. Let's assume this is an empirical formula. Now in molecular formula, they give us the weight of the compound for us to find the actual compound. Remember in empirical formula we discussed that it gives us the element found in the compound but not the real compound. Now molecular formula tells us the real compound. It tells us the atoms that are the real atoms that are in that compound. All right, so they assume this is an empirical formula. Now it will possibly give us the mass. Then we have a n. This n value is the value that is like a whole number, a whole digit that will multiply inside, or it will tell us that this is the molecular formula of the compound. Now let's proceed with this question for us to know what we are talking about. All right, the question here is said the compound diazine containing only carbon, hydrogen and oxygen, when 0.956 gram of diazine is burnt, it gave us 1.91 gram of CO2, then 0.782 gram of H2 are formed. In other experiment, it will determine that 6.04 times 10 to the power minus 3 moles of diazine weighed 0.532 gram. What is the molecular formula of diazine? All right, so we already have the idea of empirical formula, so we're going to be using the empirical formula process for us to find the molecular formula. So now, making it straight, we have here as 0.956 gram of 1.91 gram of CO2. So we have for carbon the mole is equal to the mass 1.91 over the molar mass, which is 44. Then we have an approximate value of 0.0434. all right, so carbon here is 1, so multiplying here 1 changes nothing. So for hydrogen here we have the mole we have 0.782 over hydrogen, that is water, which is 18. Then we have here as 0.04344 approximately. For hydrogen here, hydrogen is having an atom as 2, so we're multiplying here with 2. So we have here as 0.0869. Okay, it's approximately more. And for us to find the mass of carbon hydrogen, we have to convert the moles to grams. So remember, for carbon, mass is equal to mole times molar mass, which is same as what is the mole here? We have 0.0434 times carbon is 12. All right, we have here as 0.5208 gram. Then for hydrogen, we should have the mass as 0.0868 times hydrogen 1, which is same value. Same value, 8. All right, so here we already have the masses of carbon and hydrogen. Now what to find the mass of oxygen, because they actually said diazine contain carbon, hydrogen and oxygen. All right, so to find the mass of hydrogen, since the mass of oxygen, since we already know the masses of the two of them, so we should have carbon plus hydrogen plus oxygen will be equal to the mass given to us for diazine, which was 0.956 gram. All right, so we already know for carbon, hydrogen, or to find for oxygen. So oxygen should be possibly, then we're collecting like we do this way. So we have here as 0.956 minus 0.5208 minus 0.0868. So we have the mass of oxygen here as 0.3484 gram. So now we already know the mass of oxygen, so we have to find the moles for us to find the empirical formula and then the molecular formula. All right, so remember, moles for oxygen, mole is equal to mass 0.3484 over the molar mass of oxygen 16, should be approximately 0.021775. all right, so now we have the mole of oxygen. Now we can, for carbon, hydrogen, oxygen, now we have the mole of carbon there as 0.0434. For hydrogen we have 0.0868. Then for oxygen we have 0.021775. Now remember, from empirical formula we are dividing with the least value. All right, so we have 0.0434, 0.0868, then 0.02175. so the least value here should be this Alright, so we are dividing by the least value here. 0.021775, 0.021775, and same goes here. So we are dividing 0.0434 divided by 0.021775. So we have here as an approximate value 2. So here we have an approximate value here as 4. Then here should be possibly 1. Alright, so our empirical formula here should be C2H4O. Now this is the empirical formula. Now we have to find the molecular formula. Now from here we have that they gave us that the mole of dioxin, which is the sample we're looking for, the compound we're looking for. Then they gave us the mass here as 0.532 gram. Now I say, what is the molecular formula? All right. So we now have from here. Remember, mole is equal to mass over molar mass. Should be equal to mole equal to mass. This is the mass, 0.532 over the molar mass, which is the weight of the compound. It is unknown, so we have to look for it for us to know. Now possibly we'll cross multiply, then this should go here, then you will come here. So we have the mass of the compound as 0.532 over 6.04 times 10 to the power minus 3, which is, as we have here, as 88.08 gram per mole. Now this is the weight of the compound. Now from here we can find the molecular formula of this compound. So for my first description, we have here as the empirical formula. So we have this C2H4O, then an N value, then be equal to the molecular formula, the mass of the weight of the compound. So now we have here as 12 the mass of carbon times 2 plus hydrogen 1 times 4, then plus 16 times 1, and will be equal to 88.08. all right, from here we should multiply and add everything there. So we have here as 44. all right, so we have here as 44 and is equal to 88.08. so now this should divide. So this n is multiplying it. 44 times n will give you 44n equal to 88.08. Then n should be equal to approximately 2. Should be an approximate value. Approximate value 2. So now this is the n value, and I told you the n value is the whole number that multiplies the empirical formula, the atoms, to know the real compound here. So now we have here this as the empirical formula, C2H4O times n, which is the same thing as C2H4O and 2. So these two multiplying each atom here. So we have here as 2 times this will give you C4, 3 times this will give you 8, this times this, so we have 2 times 1 here will give you 2. Now this is the molecular formula. Now this is the molecular formula of the compound. Alright, now if you don't understand what we are doing here, like you are confused over what I'm doing, just go back to our videos on molecular empirical formula that will guide you on this for you to understand everything we are doing here. Alright, if you don't understand on this, like you already have idea on empirical formula, watch the video over again, you'll get the knowledge you want. Don't forget, subscribe to our YouTube channel, like, then drop your comments. Alright, thank you.
Learning online haven't been more fun. Exquisite Online Tutorials is a household name when it comes to academic excellence in online tutoring of 100 level students to 100 level students and college entrance examination candidates. With the power of artificial intelligence and human studies, Exquisite Online Tutorials have been able to interact with the intelligence of students worldwide, making the good ones better and even the better ones best. Just like Science Bob, Exquisite Tutorials has a great faculty of erudite tutors that inject knowledge, whether science or business management, to the cerebrum of her students. QTME lectures and other college entrance examination lectures are going on as well. Do you still need a physical tutor? No. Exquisite Tutorials got you. Please subscribe to our YouTube channel and follow us on Twitter and Facebook.